Hey guys, it's Mr. Lowry. This is a homework assignment that I assigned on 11/18, which is Wednesday if you're in cohort A. It's the homework assignment for 11/19 if you're in cohort B, and that's a Thursday. In class today, we talked about graphs, and we did some graphing stories where we watched a video and then we try to represent that with a graph. That's going to help us kind of be able to look at a graph and interpret kind of what's happening in a graph based on like a story or a real world situation. So if you haven't done that in-class activity, if you were gone, you might want to go back to day 3 assignment and work through that activity so that you can kind of understand this a little bit better. So in this scenario here, we got a graph, and it's the water level of a kiddie pool that Tina set up, filling with water, then her little sister is playing in the pool. So we got the water level here, and it's like kind of going up and it's going down. It's got all these bumps in it, and we want to figure out what's going on. We need to kind of represent this. So you're going to answer these questions down here based on the graph, but let me give you some ideas here, okay? First off, there's a couple sections of the graph that are kind of weird. They're kind of jagged, like this guy right here and this guy right here. That's kind of weird. There's kind of some steps here if you look closely. So what's happening, according to the graph, is that the water level is at a certain height for like an amount of time, and then all of a sudden it just jumps to the next level, like instantaneously. Water level's constant, 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 and then it jumps. Water level's constant, 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 and then it jumps. Okay? So things are happening kind of strangely here. Water's getting added almost instantaneously, and so you might want to think about what that kind of means in terms of the problem. Now here we have so down here we have gaps. Here we don't have any gaps, so this is more of like a smooth, gradual increase. It's not like we're adding water, and jumping levels a little bit at a time. We're gradually increasing the water level as we go. Some of these areas of the graph are steeper than others, so I'm going to let you kind of figure out what that means in terms of water coming in. We also have some decreases. We got some jagged lines here as well, so it's kind of hard to see in the picture, but if you look closely, it's kind of like this. We got these, again, kind of steps right here. What that means is we're decreasing water in like jumps. We're going from a water level, and then like kind of instantaneously there's less water, instantaneously there's less water. So kind of keep that in mind as well. We have some decreases, we have some more increases, we have some decreases, kind of down here at the end. So all of those are kind of important here. Down here we're talking about time in minutes, so this is our time axis, this is our water level. So that will kind of help you here with these questions. Now, you still got to think about it a little bit. What I would probably do is read through these questions before you answer them, because there's some information like this one. Sometime while Tina's little sisters were playing in the pool, it began to leak. But it also tells us that Tina's sisters were splashing and splashed out some water. And it also talks about Tina was using buckets to fill up the pool. So before you go in and answer all these questions, you might want to get kind of some of the story. So there's part of the story where Tina's using buckets to fill up the kiddie pool. There's some time where there's a leak. So a pool began to leak. There's some time where there was some splashing happening. Tina's sisters were splashing, water splashed out of the pool. And those might not go, the questions don't necessarily go in order of the graph. So as you're looking at the graph, look for times look at places that could represent splashing water out of the pool, or places that could represent leaks in the pool, or places that can represent filling up the pool fast, filling up the pool slow, things like that. So kind of read through the questions, look at the graph, see if you can map it out, and then that will kind of help you answer those questions. Okay, on the back here, we need to do some key features again. All right, so I'm going to help you through one of these. I'm going to do this guy right here. One of the things to note on this graph is these arrows. These arrows mean that this graph is going to keep going forever and ever. So I'm going to see if I can zoom in here a little bit for you. It's going to be kind of hard to see, but We'll do our best. Okay, let's start with x-intercepts. So this is the x-axis right here. Whoops. And we want to know where the graph intersects that axis. So that looks like about right here and about right here. It's kind of hard to see exactly where those are at because they're in between, but we're going to estimate. If this is -1 and this is -2 and this is kind of in between, let's maybe call that -1.5. Maybe not exact, but that's close enough. Now remember, that's a coordinate, so let's write it as a coordinate with an x and a y. Okay, this guy, this is -4 right here, and this is -6. So this line in between them is -5. So this is in between -4 and -5. It's kind of hard to see exactly where it's at. Let's say -4.5. Okay, not exactly, but maybe that's close enough. Okay, so these are intercepts. These are points. Okay, the y-intercept is where the graph crosses the y-axis, and this is the y-axis right here. So we're looking for this point right down there, and that's going to be at -4. So here's the x-axis, -1, -2, -3, -4. Okay, now again, that's a coordinate, so that's 0, -4. 0 for the x, and then down 4 for the y. Okay, the maximum is the highest point on the graph. Okay, so we're talking about y values. The highest point on the graph would be this guy. Okay, that height of that point is 5. It's 5 high. And the minimum is the lowest point, but remember that these arrows mean go on forever and ever and ever. So the minimum will be -infinity, or in other words, there's not really a minimum. Okay, increasing, decreasing, positive, negative. This is the hard part. Okay, so increasing, decreasing, I'm going to give you some notes here. I'm going to do uphill / downhill. Okay, if we think of this maybe as like a hill and we have our little hiker man and he only walks to the right because we read a graph from left to right. Okay, and this guy, if he's walking uphill, it's increasing. If he's walking downhill, it's decreasing. Okay, for positive and negative, we're going to do above water, below water. Okay, now obviously this graph isn't about water per se, but we can kind of imagine that the x-axis is like the water level, and anything below the water level is negative, and anything above the water level is positive. So this above here is the positive section, and then this is the negative section. Okay, now we need to find intervals, intervals of x. So we got to break our graph up. Let's start with increasing and decreasing. Okay, so our guy walks up, and he's here. He starts to have to turn around and walk down. So there's a line that separates the increasing from the decreasing part. So let's draw that line, and that will help us with our interval. So we're going to draw a vertical line here that goes through our graph. So on the left side of that line, we're increasing because he's walking uphill. And on the right side of that line, we're decreasing because he's walking down the hill. So there's just two sections here. These arrows, remember, it keeps going down forever, so he's been increasing forever. So what we're going to do is we're going to look at the x-axis for those intervals. Okay, these intervals are going to only apply to the x-axis. So we're looking for this section of the graph. What is this section of the graph? Well, remember that this graph keeps going forever and ever, so this graph goes from -infinity, the left, all the way up to this point right here, which looks like -3. Okay, that's the section of the x-axis that we're talking about for this section of the graph. Okay, so from -infinity all the way to -3. We don't care about how high he's going. Don't worry about the 5. We talked about that already. We're talking about what part of the x-axis covers that interval. Okay, so from -infinity all the way up to -3. Okay, now the decreasing side, it starts at -3, and it goes all the way to infinity because this guy keeps going forever and ever and ever. So this section of the graph is from -3 over to infinity. So my increasing interval here is from -infinity to -3. Okay, we're using parentheses because right at this point, I'm not increasing or decreasing. Right at -3, I'm not going up and I'm not going down. It's kind of a turning point. The decreasing interval is the right-hand side of the graph, this stuff. And that side of the graph starts at -3 and goes to infinity. Okay? So just worrying about the x values. What part of the x-axis covers that interval of the graph? Okay, so positive and negative are going to be really similar, but we're just going to divide the graph in different places. So I'm going to grab a new piece of paper because I have already kind of marked this one up, and I want to be able to show you some separate intervals. So let's look at the positive negative here. All right, now this again is like above water, below water. So here's our x-axis. This is the positive section. This is the negative section. So I want to break my graph up into intervals kind of right at the x-intercepts. All right. So in this section of the graph, we're underwater. And then in this section of the graph, we're above water. And then in this section of the graph, we're underwater again, if we think of this as water. So this is negative, positive, negative. Now we just need the intervals. What sections of the x-axis? So this is one section. But remember, this graph keeps going to the left. This is the middle section where he's positive. And then this is the other section. And we want to look at these x values. So far left is negative infinity because this arrow keeps going down and to the left. Far right is positive infinity because this graph keeps going down and to the right. And then these points are our x-intercepts that we talked about. We kind of put those x-intercepts at -1.5 and -4.5. So this point right here, this x value, would be about -4.5, and this is going to be about -1.5. So I'm going to write those down here. It's a little cramped in here. I'm just going to write those values. So negative infinity, okay, this one was about -4.5. This one is about -1.5, and then over here on the right, we go to infinity. So my two negative intervals are here, and my positive interval is in the middle. So let's do our positive interval. It goes from -4.5 to 1.5. It's this section of the graph. We just do that in interval notation. So we go between here and here. That's where my graph is above the water. Okay, for my negative interval, we have two of them, this section and this section right here and this section up here. Now remember, we don't care about height. We're only talking about the x values where the graph is negative, the x values where the graph is negative. Okay, so from negative infinity all the way up to -4.5, we're in negative land. And then from -1.5 over to infinity, we're in negative land again. So we go negative infinity up to -4.5. And then we have another interval that starts at -1.5 and goes to positive infinity. And in between, to link those two intervals, we're going to put this little symbol, the union symbol that we talked about. Okay, so that is going to help you with this one. Now, this one you need to practice. It's a little bit different, though, because there's not arrows. So you actually don't have to worry about this going to infinity because it doesn't it doesn't have any arrows. What you could do if you want to is you could do like points there if you wanted to, just to know that it's going to stop. So if you're looking for increasing, decreasing, we're going to have some sections like this. And you're looking for the x value. So from here to here, you're increasing. From here to here, you're constant. And from here to here, you're decreasing. You just got to figure out what intervals there are by looking at the x-axis for those sections. Okay, now if you want positive, negative, you got to divide up the graph in a different spot, because this right here is where the graph divides for positive, negative. Here's the negative section from here to here. Again, you're looking for the x values. And here's the positive section from here to here. Again, we're looking for x values. Don't worry about the height. When we talk about increasing, decreasing, we don't care how high it goes. That's for max and min. For increasing and decreasing, we're talking about at what part of the x-axis is the graph going up and at what part is it going down. Okay? That should help you get started. The last section here, to zoom out a little bit, is just kind of one of those graphing stories. So you're going to read this story about this puppy that's like fetching a ball and bringing it back. and you're going to draw what this graph looks like. This is going to kind of go along with the graphing stories that we did in class today. So if you were gone today and you missed class, what I would do is I would go back to the day 3 post in Canvas and practice with those graphing stories so you can kind of get an idea of how to do this problem. I hope that helps, and I hope to see you guys in class soon. Thanks.